we are going to use the lumped matrix here in vibration analysis or modal analysis, whatever it is called. Here also we are going to find out the natural frequency. The only difference is here is that here that bar is constrained, but no forces are given. Bar is constrained. How to use the lumped matrix is first thing, and then how to calculate the displacements over here and apply it and find out the natural frequency of the system. Here the bar has shown in the figure length 2L, modulus of elasticity E, mass density rho, cross sectional area A. Determine the first two natural frequency. முதல் ரெண்டு natural frequency கண்டுபிடிக்க சொல்கிறோம், omega 1 and omega 2. So this is the 2L and this is displacement. Displacement is not a force, it's displacement. X is given. So some displacement is there, but here L is equal to 2L and E is equal to E, rho is equal to rho area. Now I am going to deal with this. I am going to deal with two things, 1 and 2. 1 and 2, this is here it is constrained, here it is constrained. So the bar is constrained over here. This is fixed, so here the displacement will be 0, here the displacement will be there, here the displacements will be there. So because even though there is no force, there will be a vibration because it is constrained. It is here, it is constrained. So this constrained body, we are going to find out the natural frequencies. So how to find out that? So now the same equation we have to apply. K minus m omega square p u is equal to f. That is the equation we are going. First to find out the stiffness matrix for the element 1. As I have divided, here I have divided 1, 2 elements over here, and 1, 2, 3 nodes are there. So I have divided that, and stiffness matrix for the element 1, and this is given. Stiffness matrix for the element 2, and it is also given. Now assembling the element matrix. So this is first is we have to find out that because the A, E, L are the same, rho is equal to so L is equal to L, the exact equations is coming on the way. So AE by L 1 minus 1 for the element 1, and AEL by 1 minus 1 element for this element 2. Then we are going to assemble this and this. We are going to get this stiffness matrix. Now lumped matrix or consistent matrix ரெண்டுமே யூஸ் பண்ணலாம். இதுக்கு யூஸ் பண்ணி sometimes the problem they ask the lumped matrix and the consistent matrix to find out and compare it. What will be the value? Here we will use lumped matrix. So this is rho AL 2 1 0 0 1 1 2 1 2 and 1 2 1 0 1 0. There it matrix differs. Both the matrix differs in mass matrix. Mass matrix is very much needed in vibrations. 2 3 and 2 3, these are the nodes. So m1 1 2 and 1, these two you assemble this equation. I am getting this assembled equation as this one. So now this K, now I am going to apply this. See here u1 is equal to 0. Then u1, because it is fixed, u1, why it is u1 is equal to 0? Because it is fixed at the fixed end, and u2 is equal to, there will be a displacement second element at the last and third element at the last. So there will be a displacement u2 is equal to u2, u3 is equal to u2. It means that that is a displacement, and the forces all are 0. The forces, everything is 0. So I am applying it in this one. So u1 is equal to 0. உங்களுக்கு வந்து this is this u1. So neglect the first term. So this all the term will go. So 2 minus 1 minus 1 1 2 0 0 1 will be there. So we are going to do the same simplification as we done before. So I got this equation. I got this AE 2 minus 1 minus 1 rho 2 0 0 1 u2 u3. Now dividing both by ரெண்டு இடத்துலையும் நான் rho AL by divisible by. See here the simplifications is very important. That's rho AL is just divided. See, no need of dividing. You can simplify it and find out. Your objective is find out the omega square. So you divide, you take up all these values here, you make this value here 1, so you have to divide, or something you make it in a simplification, that is a very good way. You make this as a 1, so divide whole thing by that, you will get one value. Here he has divided row AL, so row AL I have divided this, and here also row L, this is cancel, here at I am cancelling everything, and everything cancel, I am getting lambda by 2, only 2 remains over here, lambda by 2, here AA cancel, here row L square. So this and this equation. So now what I have did, this one, this is mu I have given, this is as mu I have given, mu is equal to sun, so mu this one. So now what you have to do, you minus this 2 mu minus lambda by 2 into 2. So that way you make it lambda by 2 into 2 gets cancelled, minus lambda, so 2 mu minus 2 lambda by 2, lambda 2 will cancel, that is why you are getting this formula. So this minus 1 minus mu minus lambda by into 0 minus lambda minus lambda by 0, so minus mu, so minus it. And so minus, this is also minus mu minus lambda by 2 0, so this minus mu, so 1 mu minus lambda by 2 minus, so mu minus lambda by 2. So this is the equation you got. So you will minus in subtraction, matrix subtraction, or you easy way to do, multiply this inside and then minus it, easily you will get this. So now I have to do what? Now I have to find the determinant. I will finding the determinant. So I find the decided determinant, multiplying, cross multiplying this and this and this, and setting to 0. So this is the equation set. I am getting this equations. Now this equations, this is the same thing I have written here. This equation reduce it, minus mu to minus 2 mu. 2 mu square minus mu square, lambda square by 2 is left. This is like a quadratic equation. A minus b the whole. So see, lambda square by 2 minus 2 mu lambda mu square, a minus b, it is in the same way. So quadratic equation, so we cannot solve this by factorizing method. So we are using the quadratic equation formula, minus b plus or minus b square minus 4ac by twice a. So b is what here lambda we have to find, minus 2 mu is the b. But this mu is 1, then 4a is mu, and c is lambda square by 2. So in that way you substitute here, right? A is equal to what, b is equal to what, c is equal to what, then substitute in the equation. There will be no mistakes in that. So this equation I substituted, I got lambda 2u plus or minus mu root mu. So mu I take it out, so this value I got. So lambda 1 is equal to 3.41 mu it will be mu, and lambda 2 is equal to minus 5.85 mu. So lambda is equal to, we know that we set that lambda is equal to, there we have set the lambda is equal to omega square. So omega is equal to lambda. So omega is what is lambda here? This is the value. What is mu here? That we know. So this value. So what is the mu? That is what I have substituted here. First I have take the root 3.4, it is 1.85. For mu I have substituted this value. So I got this. So omega 1. So again omega 2. Omega lambda value is 0.85, that you substitute. Omega 2 is equal to 0.585 root of mu. So this root you get 0.76 mu radian per second. 76 e by rho L square. So you get W2. This is the way to find out the constrained, when the bar is constrained, with the Lambda matrix. And tomorrow we will see, next video we will see the how to use lumped and consistent matrix, and also we will see the beam problem, that is transverse vibration. Transverse vibration is the force is perpendicular to the axis of the beam. How we can apply lumped and consistent matrix, stiffness matrix, and we will find the finite element equation. Thank you.